Welcome everybody. We have this equation 3 raised to the power of 3x positive 3 raised to the power of x is equal to 30. We are expected to find the value of x. Now this particular equation can have both real roots and complex roots. But the question is, how many real roots can this system have? That answer is simply straightforward, because if you were to observe this given system 3 raised to the power of 3x followed by 3 raised to the power of x is equal to 30. This is an increasing function, and 3 raised to the power of x, this is also an increasing function. Now the composition of these two will in turn give us an increasing function. On the right side you got a constant 30. Now for this equation to hold good, the increasing function that we have on the left side should meet with the constant on the right side. So the increasing function has to meet the constant 30. And since we have two increasing functions which combined together gives us one increasing function, the only possibility for this increasing function to meet at the point 30 will occur at just one point. And if that point is some x, that is element of real number. So what I'm trying to convey here is that this particular system will have only one real root. Why do I say that with confidence? For the simple reason that I have an increasing function coupled together with another increasing function, and these two increasing function has to intersect at the value 30, and that is only going to be possible at one particular point. That is the reason I am saying it in confidence that there will only be one real root for this particular system. So I can just state that this system or this equation will only have one real root. That's it. Nothing else more than that. And I can show that to you. That real root, I can find that real root and I can show that to you. So foremost, what I will do is I will just start off by consider 3 raised to the power of 3x positive 3 raised to the power of x is equal to 30. Then what I will do is I will rewrite this as 3 raised to the power of x whole raised to the power of 3 followed by 3 raised to the power of x is equal to 30. Now let me just let 3 raised to the power of x be equal to some t. So this is going to be t cubed positive t is equal to 30. Now let me bring this 30 to the left. So this is going to be t cubed positive t negative 30 is equal to 0. Now I would like to rewrite t as 10t negative 90 followed by negative 30 is equal to 0. This is acceptable, right? Fair enough. So having got that, what I would do is I will move this 90 towards t cubed. So let me write it like this fashion: t cubed negative 90 followed by 10t, and this negative 30 is equal to 0. Now I will club these two together and these two together and rewrite this as t of t squared negative 9 positive t of, in fact I can take 10 out. If I were to take 10 out, I would get t negative 3. 10 into t gives me 10t, 10 into 3 gives me, with a negative sign, gives me negative 30. So that's looking good. Now we know the formula a squared negative b squared is a negative b times a positive b. So t squared negative 9 can be rewritten as t squared negative 3 squared, which can be rewritten as t negative 3 times t positive 3. So this is going to be t of t negative 3 times t positive 3 positive 10 times of t negative 3 is equal to 0. Now clearly t negative 3 can be taken out, and that would mean I now have t of t positive 3 positive 10 is equal to 0, which is nothing but t negative 3 of t squared positive 3t positive 10 is equal to 0. So from here I have t negative 3 is equal to 0, and the other system is going to be t squared positive 3t, positive 10 is equal to 0. Fair enough, right? So from here t is equal to 3, but I have taken t to be as 3 raised to the power of x. So but t is equal to 3 raised to the power of x. So this would mean 3 raised to the power of x is equal to 3, and clearly you can see that if I were to have the index as 1, the bases are same, so this would mean x is equal to 1. Now of course many of you all would have found that out, x is equal to 1, but the most important claim is the justification that x is equal to 1 is the only real root. So that is the important part we need to answer, and which I've already explained to you here. Now coming back to this other system, this system is going to be producing only complex value. So I can show that to you. So t is equal to negative 3 plus or minus, this is going to be 3 squared, negative 4 times a times 10 divided by 2 times a, which is equal to negative 3 plus or minus root of 3 squared is 9, negative 4 into 10 is 40 divided by 2. So clearly if you are going to be looking into the complex roots, t1 is going to be negative 3 plus root of, this is going to give me negative 31 divided by 2. The other one is going to be negative 3 negative root of negative 31 divided by 2. Of course you can use the presence of complex numbers and write it as t1 is equal to negative 3 negative 31, that can be rewritten as root of 31 I squared divided by 2, right? And which can be subsequently rewritten as negative 3 plus I times root of 31 divided by 2. And for the other t2, that's going to be negative 3 negative I times root of 31 divided by 2. So you got the presence of these two complex values, and since t is equal to 3 raised to the power of x, you can rewrite it as 3 raised to the power of x is equal to negative 3 plus I times root of 31 divided by 2, and subsequently the other value is going to be 3 raised to the power of x is equal to negative 3 negative I times root of 31 divided by 2, and you have to use logarithms, use log to find the value of x. Of course the system only wants us to produce real roots, and I think this is the right place for us to stop with the value of x, which we have found out to be equal to 1, and clearly you can check that value, check. So 3 raised to the power of 3x, 3 raised to the power of 3 times x, positive 3 raised to the power of x should be equal to 30. If we were to take x is equal to 1, this is going to be 3 raised to the power of 3, positive 3. This is 27 added with 3 will give us the right hand side. So that is the solution for this beautiful question. Thank you everybody.